Hello everyone, this is Mark, and today we're going to look at a relatively new feature called tracing within the MiNiFi C++ agent. In front of you have two terminals. The one on the right is the MiNiFi agent that I'm going to run manually, and on the left we'll have a MiNiFi controller command that runs what we call a JStack. A JStack is an homage to the tracing done in Java. So if you're familiar with Java, especially with NiFi proper, you'll know that JStack is a command that people may use to inspect the currently running Java process. Myself, having worked many years with Java, I'm very familiar with using that in an operational environment. The goal here with the MiNiFi controller, as we've dictated in some of our documentation, is that this provides you capabilities either locally or remotely to perform some operations within against your running MiNiFi agents. This uses some of the protocols we've defined in our C2 documentation. But the most important thing for today's video is that what we're going to look at are running JStack or running stack commands within the MiNiFi C++ agent. This is implemented in a nearly identical way that the Java JVM implements, or rather the JVM implements are JStack commands, in that a signal handler is called, threads are effectively stopped at the point at which they handle those signals. The point I'm making with that is that we're certainly running something that is impactful to performance long term if performed constantly, just as a JStack performs many of the same locks for signal handlers within the JVM. Today we have a very simple flow of generate flow file to an RPG. That input port on the NiFi instance, as you can see with log attribute, simply logs that information out. There's very little that is being done from a process perspective. That's important to note now because our flow is generally I/O bound. I mention that simply because when we look at the JStacks, we may actually see more information and stops from RPG interfaces than we will from generate flow file. I'm not actually sure we can show generate flow file because it runs very quickly and it sends the data to the process session and ultimately down to the repository. So I'll move that out of the way and start our MiNiFi process. The JStack command uses the MiNiFi controller. I've made other videos about this, but you can see MiNiFi controller can connect either to a local host, as we'll see today, or a remote host if the agents are configured to accept that. What we'll be running today is the JStack command. As you can see, right off the bat, we run it and we run into threads that are actually performing operations. Typically in most thread pools, you'll see a lot of waiting, and I think this is common even from our thread pool. We attempt to minimize it as much as possible, but of course, as you'll see with any executor service or any thread pool in any language, most of the time you'll be sitting there waiting if you're running an I/O bound process, as we are with generate flow file. In this case, you can see scheduling agent 0 through 3 two times. The first is the timer-driven scheduler, and the second is the event-driven. You'll also see flow file, which may pop up every once in a while, and then you'll see main. Main is really unimportant here. The flow file repository, I think, would be important if you were trying to diagnose something, perhaps that was an issue on local disk. We'll tail the file. We can see, for one, back pressure is causing us some issues. As I move over to NiFi, obviously, NiFi will remove and perform some of these logs and boluses, meaning that we send a large chunk, and this could be MiNiFi side or NiFi side. I haven't really taken much of a dive into it, but again, we run the JStack command and we get our stacks. What we see from this stack is that we have the timer-driven scheduling agent, which is our scheduler, that has a thread pool. That thread pool runs on RPG and is performing the operation of our site-to-site. In this case, I think I saw that we're using raw site-to-site rather. We run it again, and actually we see something a little bit different. Perfect. We see the thread pool running our scheduling agent, while it's also and running 2 instances of generate flow file. I've configured this to use 7 concurrent tasks in hopes that while recording we run into the case where we see generate flow file. We see the onTrigger call, which is writing to local disk. That is writing to a file system repository, which is an instance of a content repository in our code base, and writing that to local disk. Run that again, we see waiting threads. As you run this many times, as you would with JStack, you could certainly see that you'll have the signal handler will interrupt the thread at any given point. In this case, we can see that RPG calling site-to-site code, performing the CRC checks, and for whatever reason, I believe, if I'm not mistaken, my logger is set to trace, so it stands to reason that for whatever reason, we're going to hit a lot more logger statements, and that's not uncommon. I think even in Java, I've experienced that constantly. If you have it set to trace, that's going to be an impact that you see. What I'd like to do is go back to a watch command. Obviously, you may not be able to capture a lot of this in the video, but if we watch it every 1 second and we're showing the diffs, you can see there's a lot of activity that happens. Again, when you're running this stack command, there is a lot that is going on underneath the covers, meaning that there are a lot of thread management. There's a lot of thread management going on. So in this case, we're running the file system repository, or rather the flow file repository, using RocksDB. That's enabled in this agent. We can see that as we run the scheduler and we run the processor, we place and we commit our session, or rather we put our flow file into the connection. We're putting that into the repository, and we can see that very clearly with this thread dump. So in this case, we can obviously see that here's a very interesting case, something that you'll see in Java as well for various locking constructs, but this process session is calling the logger, which is also then calling a mutex lock. That's interesting to note. I don't know if this log statement is trace, info, or debug, but I do know that we see the lock, and if this were something that came up a lot, I would certainly take a look. So as I've shown here, we can run this MiNiFi controller command, and hit, in this case, locally. The documentation that we have in our README on GitHub provides information and insight into how to run the MiNiFi controller command. Effectively, it requires 1 or 2 configuration items for the command and control interfaces. They're simply an object or class that you specify in the configuration, and you can get this. This binary is produced from our regular build. There's nothing that you have to specify differently. The JStack command provides you the backtraces for all of the threads. This obviously requires that you build with debug symbols to make this the most beneficial. And every platform will have slightly different ways of providing these symbols. So for example, Mac OS X won't necessarily provide the same function calls in the same exact way. So you have to be cognizant of that. We don't make any attempt to normalize across platforms. This feature, as of this day in October 2018, is not implemented in Windows, but it will be as soon as we have an opportunity to do so. Thanks for watching, and I hope you have a little bit more insight into how you can debug and work with MiNiFi agents in a production environment. If you have any questions, email the NiFi dev mailing list and we'll be happy to answer. Thank you.